Concrete is everywhere around us and is the most commonly used man-made material on Earth. Due to its good strength and reputation against compressive loads, most buildings, bridges, roads, and dams are constructed with concrete. Concrete is intrinsically resistant to compressive stresses, but its resistance to tension is much lower. Studies indicate that on average, the tensile strength of concrete is about a fraction of its compressive strength, generally less than 10%. This weakness of concrete is responsible for almost all kinds of cracks in structures. Generally, we provide steel reinforcements in concrete to avoid these tensile cracks. Still, the cracks appear due to the fact that concrete strains more than steel at a given stress, and when stress in concrete reaches a certain limit, it starts bending and results in cracking. For this purpose, a system, known as prestressed concrete, was developed to control unwanted deflection and cracking in structures. To provide adequate precompression in the concrete beam by tensioning the steel wires, cables, or rods that under working conditions concrete has no tensile stresses, or the tensile stresses are so low that no visible cracking occurs. Hello, and welcome to Engineering Concepts. Today we will discuss about the prestressed concrete. What is prestressed concrete? Prestressing itself means an intentional application of a predetermined force on a system to introduce internal stresses. As a result, it enables the concrete to counteract those tensile stresses which are produced in concrete when it is subjected to service loads. Who invented prestressed concrete? Eugene Freyssinet, a French structural and civil engineer, was the major pioneer of prestressed concrete. He felt the need to develop high-quality concrete and high-strength steel that were necessary for the invention of prestressed concrete in 1928. Why do we use prestressed concrete? As discussed earlier, that concrete is extremely weak in resisting the tensile stresses. It starts cracking after a certain point under tensile stresses. The undesirable deflection and cracking are huge serviceability and durability issues. Serviceability implies that deformation of structures such as deflection, cracking, and other distortions under load shall not be excessive. Otherwise, the structure will not serve its intended purpose. Durability implies that if the cracking is not controlled or mitigated, it could lead to the intrusion of damaging waterborne salts, which in turn can lead to the corrosion of steel within the structures, hence decreasing the service life of structures. Prestressing can considerably reduce the undesirable deflections and hence limits the cracking by minimizing the tensile stresses in individual members, hence boosting durability and service life of the whole structure. What is the principle of prestressing? The principle behind prestressing is applied when a row of books is moved from place to place. Instead of stacking the books vertically and carrying them, the books may be moved in a horizontal position by applying pressure to the books at the end of the row. When sufficient pressure is applied, compressive stresses are induced throughout the entire row, and the whole row can be lifted and carried horizontally at once. In case of prestressed concrete in a beam, the applied pressure is introduced by tensioning the steel cables or rods with the help of jack and anchoring the steel at the ends. When jacks are released, the tensioned steel tends to regain its original length, but as it is anchored on both ends and hence exerts compressive force on concrete. What are the materials required for prestressed concrete? High-strength concrete. Use of high-strength concrete results in smaller sections. High-strength concrete offers high resistance in tension, shear, bond, and bearing. Less loss of prestress occurs with high-strength concrete. High tensile strength steel. Ordinary mild steel and deformed bars used in RCC are not used in PSC, prestressed concrete, because their yield strength is not very high. In the prestressed concrete, loss of prestress, about 30%, occurs due to many factors that we will discuss in separate video. If mild steel is used, then very little prestress will be left after the losses and will be of no use for us. Therefore, high tensile strength steel is used for prestressing. In addition to the high strength, the steel used in prestressing must have a higher ultimate elongation. Various forms of steel used for prestressing are round wires, Wires are normally bundled in groups of up to about 50 individual wires to produce prestressing tendons of the required strength. Stranded cable. Stranded cable, more common than wire in US practice, is fabricated with 6 wires wound around a seventh of slightly larger diameter. Tendon. A collection of strands encased in a duct, only used in post-tensioning. Alloy steel bars. Available in the form of deformed bar similar to reinforcing bar. What are the advantages of prestressed concrete? Objectionable deflection and cracking, which would otherwise be associated with the use of non-prestressed reinforced concrete members at high stress, are easily controlled by prestressing. Prestressing extends the range of application far beyond the limits for ordinary reinforced concrete, leading not only to much longer spans with economical member cross-sections than previously thought possible, but permitting innovative new structural forms to be employed. Prestressing results in the overall improvement in performance of structural concrete used for ordinary loads and spans. The prestressing of concrete has several advantages as compared to traditional reinforced concrete, RC, without prestressing. A fully prestressed concrete member is usually subjected to compression during service life. This rectifies several deficiencies of concrete. What are the disadvantages of prestressed concrete? It requires high-strength concrete and high-tensile strength steel wires. The use of high-strength materials is costly. The main disadvantage is construction requires additional special equipment like jacks, anchorage, etc. There is additional cost in auxiliary equipment. It requires highly skilled workers under skilled supervision and technology. Due to all the above-mentioned reasons, construction cost of prestressed concrete structures is little higher than RCC structures. What are the types or methods of prestressing? And which is better, pretensioning or post-tensioning? Pretensioning. In pretensioning, the steel is stretched before the concrete is placed. High-strength steel tendons are placed between two abutments and stretched to 70 to 80% of their ultimate strength. Concrete is poured into molds around the tendons and allowed to cure. Once the concrete reaches the required strength, the stretching forces are released. As the steel reacts to regain its original length, the tensile stresses are translated into a compressive stress in the concrete. Post-tensioning. In post-tensioning, the steel is stretched after the concrete hardens. In this method, hollow steel or PVC ducts are placed in the formwork and concrete is cast around. Once the concrete has hardened to the required strength, the steel tendons are inserted and stretched against the ends of the unit and anchored off externally, placing the concrete into compression. Where is prestressed concrete used? In building structures, as precast prestressed beams, columns, slabs. In bridges, as pretension slabs and girders, post-tension balance cantilever as well as box girder bridges, segmental bridges etc. In dams, as post-tensioned anchors to provide additional stability. In silos and tanks, circumferential tendons to counter hoop stresses. In nuclear and blast, as post-tensioned high containment structures to avoid leakage. In hardstand and pavements, to control cracking due to heavy traffic loads. What are design concepts of prestressing? Precompression concept. Prestressing applies a precompression to the member that reduces or eliminates undesirable tensile stresses that would otherwise be present. For example, concrete in a beam or any other structure is sufficiently precompressed by transferring the prestress force from prestressing tendons to concrete. In this way, when actual load is applied during the service stage, tensile stress is produced in the lower portion of the beam and the precompression stress in concrete balances the tensile stress. Load balancing concept. Load balancing is a design method for prestressed structural members, primarily beams and slabs, that provides efficient use of materials. When using load balancing, the prestressing tendon is designed for a prestressing force and eccentricity in order to balance all or a portion of the service loads. Load balancing involves resisting the design moment by draping the prestressing strands in a parabolic pattern to mimic the moment diagram. Based on this concept, the downward gravity load is balanced by the upward component of the prestressed steel. This ensures the member only resists the moment found at that particular section of the member. Thus at the ends, where no moment is found at a simple span, the eccentricity is 0. And at the mid-span where the moment is maximum, the eccentricity is maximum. Thank you for watching the video and let me know what you think.